Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration by reverse differentiation. This is part 4. If you have missed out on any other part, I encourage you to do so, as they carry a lot of insight. Now, let's proceed. If you have dy dx is equal to f of x, then it means that the integral of dy dx is equivalent to the integral of f of x dx. We can also express our y in terms of capital letter f of x plus c. The one that was not integrated was small letter f of x, and the one that is now integrated carries the capital letter f of x plus the c. We do so to differentiate between the one that was not integrated and the one that was integrated. Now, if the f of x, small letter, before differentiation is known, then the derivative of capital letter of f of x can easily be obtained. This approach is beneficial when dealing with complicated integration problems. Let's take a look at example 1. Differentiate 2x squared minus 1 raised to the power 5 with respect to x. The b part, hence find the integral of x times 2x squared minus 1 all raised to the power 4 dx. So we would start with letting y be 2x squared minus 1 all raised to the power 5. And recall from differentiation, if we had y is equal to f of x all raised to the power n, in order to differentiate that, we would have dy dx as n times f prime of x times f of x all raised to the power n minus 1. This is what we would refer to as equation 1 from time to time. Great. Moving on with answering the question. So for A, we substitute for all the values that we have. For instance, our n is 5. Then if we differentiate what is within the parentheses or brackets, we would get 4x. That is to say then, dy dx is 5 the n times the derivative f prime of x 4x times the function f of x 2x squared minus 1 raised to the power n minus 1, which becomes 4 in this case. We simplify what we have, we get 20x times 2x squared minus 1 all raised to the power 4. That is our differentiation. That answers part A. We move on to part B. With part B, the whole idea here is we are trying to go back to where we started from. So, with what we have inside the integral sign, we are trying to manipulate it so that it looks identical to the derivative that we obtained in A, which we can easily reverse to where we started from. So in B, we see that we have x times 2x squared minus 1 all raised to the power 4. For that to be identical to what we have in A, we can multiply by 20 and divide by 20 at the same time, which is equivalent to just 1. So if we do so and we take out 1 over 20, we leave the 20 inside the integral function. We are going to have the inside being identical to the derivative that we obtained in A. And with that, we can easily reverse so that we get 1 over 20 times 2x squared minus 1 all raised to the power 5 plus c as our final answer. I hope that makes sense and I hope that is clear, but I'm sure it is clear. Let's have a look at question 2. So with example 2, we have differentiate x cubed minus 2x squared plus 5, all raised to the power 7 with respect to x. Now B, hence find 4 times 3x squared minus 4x times 3 cubed minus 2x squared plus 6 plus 5, all raised to the power 6. Now we let our y be the function that we have. So with that, we also consider how we differentiate a function f of x raised to the power n, equation 1. We now substitute for what we have. For instance, our n is a 7 here. And if we differentiate the inner part of that function, for instance, when we differentiate x cubed, we get 3 times x squared minus 4x times the function itself, x cubed minus 2x squared plus 5, all raised to the power 6, which is n minus 1. So 7 minus 1 gives us a 6. So with that, we get our dy dx as that. We move on to the b part. So with part b, we are given that whole chunk there. So we are asked to integrate it. Now we compare that with what we had in part A. So with part A, we see that we have a 7, yet in part B, we have a 4. So in order to deal with that, we take out the 4, we place it out of the integral function, and introduce a 7, at the same time divide by a 7. Why? Because 7 over 7 is as good as 1. So multiplying any number by a 1 does not change that particular number or function. So we do that. As we do that, we would have a 4 over 7 outside the integral function, and inside we have something that is identical to what we obtained in part A. So meaning that we can reverse what we have to where we started from. So in that case, we are going to have 4 over 7 times x cubed minus 2x squared plus 5, all raised to the power 7 plus c. Great. Let's move on to the last example. So with example 3, we have differentiate 1 over 4 minus 3x squared with respect to x. B, hence find the integral of 3x all over 4 minus 3x squared all squared. As usual, we let y be the function, but remember from the laws of indices, we are going to have 4 minus 3x squared to the power minus 1. Why? Because it's easier to work with a function expressed in this form. Now, so we recall how we differentiate a function raised to the power n from equation 1. We substitute for the n, we substitute for the first derivative, and we substitute for the n minus 1. In that case, we are going to have minus 1 times minus 6 times 4 minus 3x squared, all raised to the power minus 2. And simplifying that, we get 6x all over 4 minus 3x squared, all raised to power 2. So that is our derivative. Now, moving on to the part B. With part B, with what we are given here, we have a 3x instead of a 6x. So the whole point is to make that 3x be a 6x, but without changing the question altogether. So we can do so by multiplying the 3x by a 2, at the same time divide by a 2, because that is simple manipulation. Now, what we see is that the part inside the integral function is identical now to the part that we obtained in the differentiation. And with that, we can easily reverse the differentiation carried out to the form that we had before the differentiation. And then our answer becomes 1 over 2 times 4 minus 3x squared plus c. As easy as that. Thank you so much for watching Numbers Simplified. I leave you with the task. Remember, your feedback and your questions and suggestions are of great value to us, share, like, and comment. Don't forget to subscribe. Thank you once again for watching Numbers Simplified. God loves you.